Hello, my name is NKee, and this is my Module 1 presentation on myself, how students learn science, and my STEM perspective. I currently teach 8th grade math at Unami Middle School, which is located in the Central Bucks School District. I have been teaching here for 6 years, and I teach 8th grade geometry, algebra 1, and pre-algebra. My bachelor's degree is in secondary ed math from Penn State University, and my master's of education is from Cabrini University. I'm currently pursuing my STEM endorsement through Millersville. I believe that a STEM program supports my own teaching style. I really like to promote conceptual understanding within my classroom as opposed to just procedural understanding, to give students a power over their own learning and to help promote risk-taking in the classroom. I also hope that it will allow students to develop a passion and a sense of accomplishment. My favorite hobby is baking. My favorite outdoor activity is running. I just finished my 6th half marathon, and last year I was married in Newport, Rhode Island to my high school sweetheart. The current question we're going to talk about is how students learn science. There were 3 main principles that were discussed in Chapter 1 and Chapter 9 of our readings, and the first principle is about student preconceptions. Students learn new concepts based off of what they currently understand and often walk into a science class believing that what they believe is either right or wrong, and it's important for us to question these beliefs. Teachers should focus on student preconceptions to help create a qualitative understanding. Research shows that students that create an understanding of concept outperform those that do not. The second principle that was discussed was students' experience with inquiry. If we focus on inquiry, we can focus on a conceptual understanding of a concept. It's important to integrate the content as well as inquiry in the classroom to develop these understandings. The third principle that was discussed was that students should reflect and pose their own questions in the classroom. We can allow for a choice of topics and for constant questioning on their current beliefs. Students that were reflective throughout assessments show that they outperform those that are not reflective. It's important to reflect on what and why we are doing current experiences in order to develop these understandings. The next discussion is about how students do science. When I was in school, the scientific method was based off of just observation, reason, and experiment. But it's important that today we implement student imagination. Science inquiry should not be strictly teacher instruction, but should be student-led. It's important that students come into class realizing that science is not just factual, but they should question their own beliefs, and that students should engage in the process of inquiry, which means that inquiry time is blended with content and it's not separated from one another. We should let our students be a part of this creative process and encourage students to question and to take risks. The barriers that are presented in a learning environment for a science classroom are the preconceptions that our students walk into the classroom with based off of their experience. It's important to know that we can't believe what we read and what we hear, but we must really investigate and test our own current beliefs. Our instruction does not necessarily require students to create their own questions about what they're learning. Although I teach in a math classroom, it's important to realize that students in a math classroom, similarly to that of a science classroom, we need to re-examine and reshape their knowledge by knowing what they know. Knowledge and instruction must be more than just a procedural. Inquiry is a method, not just content-based, and we must generate good questions. Formative assessment needs to be used in order to decide what to do next with our students. We must promote a culture of communication, and we must really realize what drives our instruction and our content. Lastly, my STEM perspective is that I believe in creating a classroom environment to promote risk-taking, communication, and connections in order to engage our students to create deeper understanding of concepts. I don't believe that it's just about one content, science, technology, engineering, or math, but we really need to integrate these disciplines in order to create a solid understanding of how things work around us and to promote questioning. I also think a STEM seminar is an interesting approach in terms of a graduation project. And lastly, my Easter egg answer is a Kit Kat.